So today we will study laws of exponents for real numbers with rational exponents. Here we have taken two real numbers a and b, where b is greater than 0, a and b both are greater than 0, and p and q are rational numbers, and they may be negative rational numbers also. Children, you have studied laws of exponents in the previous classes as well, but you have never studied laws of exponents with rational exponents. Okay, so this time we are going to take the exponents as rational numbers, means they can be in the form of p by q as well. So let's start with the first law. It says a raised to the power p multiplied by a raised to the power q gives us a raised to the power p plus q. This law you are already familiar with, that if the bases are same in multiplication, the exponents they get added. Let's take for example, if you have a number, say a and b are any two real numbers I told you, so let's take a to be any real number. Say I take it as 3 by 7 raised to the power 5 into 3 by 7 raised to the power 3. So the answer will be 3 by 7 raised to the power 5 plus 3, which is equal to 3 by 7 raised to the power 8. Second law is, if a raised to the power p divided by a raised to the power q is equal to a raised to the power p minus q. Again, let's take one example here. For example, if I take say 7 raised to the power 8 divided by 7 raised to the power 6 will give us 7 raised to the power 8 minus 6. That means 7 raised to the power 2. It means in division, again if the bases are same, then the exponents get subtracted. P minus q you will get in the power. The third law is a raised to the power p raised to the power q is equal to a raised to the power p into q, which we sometimes write as a raised to the power pq. It means if there are two powers for the same base, those powers they get multiplied. For example, 2 raised to the power 3 raised to the power say 4 gives you 2 raised to the power 3 into 4, which is 2 raised to the power 12. Then law 4 says that if you have the bases are different but the exponents are same, a raised to the power p into b raised to the power p will give us a into b raised to the power p. Means here the bases were different but the exponents were same. So we took both the bases inside the same bracket and the exponent was common for both. For example, I can write say 7 raised to the power 3 into 4 raised to the power 3. I can write it as 7 into 4 raised to the power 3, which is equal to 28 raised to the power 3. Similarly, you have a law for division also, that says a raised to the power p divided by b raised to the power p can be written as a upon b raised to the power p. For example, say 7 raised to the power, or let's take some other example in which, suppose I take 28 raised to the power 4 divided by 7 raised to the power 4 will give me 28 divided by 7 raised to the power 4, which gives me 4 raised to the power 4. And now law 6 is for negative exponents. Say a raised to the power minus p is equal to 1 upon a raised to the power p, which can also be written as 1 upon a raised to the power p. That means if there is a negative exponent and you want to make it positive, we take the reciprocal of the base. For example, this law you have already studied in class 8th. like 2 raised to the power minus 7. I have to make this exponent positive. For minus 7 to plus 7 I want to make. So what I have to do, I have to take the reciprocal of the base. Here the base is 2. So reciprocal will be 1 by 2. 1 by 2 raised to the power 7, or it can also be written as 1 upon 2 raised to the power 7. Let's take one more example. Say 3 by 2 raised to the power minus 5 can be written as 2 by 3 raised to the power 5, because we have changed the exponent from negative to positive. So we have taken the reciprocal of the base. Here the base is 3 by 2. We have taken the reciprocal, which has come out to be 2 by 3. On the other hand, if you have something like 7 by 4 raised to the power 5, positive exponent, and I want to change it to negative exponent, then also I can write it as 4 by 7 raised to the power minus 5. That means whenever you want to change the sign of the exponent, whether it is from positive to negative or from negative to positive, we always take the reciprocal of the base. Now law 7 you are already familiar with is that a raised to the power 0 is equal to 1. Any real base raised to the power 0 will always give you 1. Now we have law 8, which is very important. Suppose I say a raised to the power p by q. This is a rational exponent. Now this can be written in two different ways. One is a raised to the power p raised to the power 1 by q, or I can write it as a raised to the power 1 by q whole raised to the power p. If you look at it very carefully, we have already done in law 3 that whenever there are two powers to the same base, they get multiplied with each other. So this will become a raised to the power p by q. Even this will become a raised to the power p by q. Now the question arises, what is the meaning of this? Let's take for example, I have say 32 raised to the power 2 by 5. I can write this in two different ways. One way is 32 raised to the power 2 whole raised to the power 1 by 5. Another way is 32 raised to the power 1 by 5 raised to the power 2. Okay. Now look at the second possibility first, which I have taken as 32 raised to the power 1 by 5 raised to the power 2. Now what is the meaning of 32 raised to the power 1 by 5? As I told you in the very beginning, 32 is power 1 by 5 can be written as fifth root of 32, and then there is whole square on that. Now what is fifth root of 32? 32 can be written as 2 to the power 5. So that comes out to be 2 and raised to the power 2, which is equal to 4. So it has become very simple. But if I take it the other way, 32 square raised to the power 1 by 5, it means first I will multiply 32 2 times, whatever answer will come, I'll write here, say 1024, and then raised to the power 1 by 5. Again I will write 1024 as 2 raised to the power 10 raised to the power 1 by 5, which is equal to 2 raised to the power 2, which is equal to 4. So that means the best way always is the second one. That is, first you take the denominator, that means the root part, and then you take the power. That will always help you. Now law 9th is, if you have a pth root of a raised to the power p will always be equal to a. This I have already told you many times while doing the questions. While writing down the simplest form of irrational numbers, I have told you, whenever the order of the radical sign and the power of the number are same, we get this number out of the radical sign. For example, if I say fifth root of 2 raised to the power 5, what do I write? 2. If I say seventh root of 3 raised to the power 7, what do we get? 3. So this is how this law is used. Then law number 10 is, suppose you have something like pth root of a. That can be written as p into qth root of a raised to the power q. This law we have used while doing the multiplication of irrational numbers. For example, suppose if you want to write the cube root of 2. Okay, this is given to us, but we want to write down as sixth root. So in order to make this the sixth root, I will write 3 into 2, and the same 2 will be raised to the power also here. That will become sixth root of 4. Now let us see exactly where is this law actually used. If you remember, while doing the multiplication, cube root of 2 into square root of 3, if I have to multiply these two, then I told you the two irrational numbers can be multiplied only when their order of radical is same. But here it is different. So what we do, first we find out the LCM of these two, that is equal to 6. So I want to make both of the orders to be equal to 6. So if I want to make it to be 6, so I have to multiply 3 with 2, and the same number 2 will be raised as a power to the inside number, which becomes sixth root of 2 square, which is 4. Similarly, square root of 3, if I want to make it the sixth root, so 2 needs to be multiplied by 3, and here the same number 3 will be raised as a power to the inside number, so it will become sixth root of 27. And then these two numbers can be easily multiplied because they have got the same radical, same order of the radical sign. So which can be written as sixth root of 4 into 27, that is equal to sixth root of 108. Now let us solve some of the questions based on laws of exponents. Like this is the question here. First we write the numerator as 4 divided by, now 216. What is the prime factorization of 216? You can actually find out, or orally if you want you can do it like this. Shortcut method. 216 is the cube of 6, but 6 is not a prime number. So prime factorization is 2 cube into 3 cube. You can actually do it and you will get to know. So 2 cube into 3 cube raised to the power minus 2 by 3, plus what is the prime factorization of 256? That is 2 raised to the power 8, then raised to the power minus 3 by 4, plus 2 upon 243 is prime factorization is 3 to the power 5 raised to the power minus 1 by 5. So what do we get here? 4 upon. Now when I open this bracket, okay, here if you want you can write it as 6 to the power 3 also, okay, because ultimately we want that this should be cancelled out with the denominator here. So this is, if I write 6 cube raised to the power this, even then what do we get here? 6 raised to the power 3 into minus 2 by 3. So this 3 and 3 will get cancelled here. Here it is 2 raised to the power 8 into minus 3 by 4. So 4 to the 8, and here 3 raised to the power 5 into minus 1 by 5. So that gives you 4 upon 6 raised to the power minus 2 plus 1 upon 2 raised to the power minus 6 plus 2 upon 3 raised to the power minus 1, because 5 and 5 will also get cancelled. Now this can be written as 4 into 6 raised to the power 2 plus 1 into 2 raised to the power 6 plus 2 into 3 raised to the power 1. We have used the law of negative exponent. As I told you, if you want to change the sign of the exponent, we take the reciprocal of the number. Just look at it in detail. I'll just explain you once again. 4 upon 6 to the power minus 2 can be written as 4 into 1 by 6 raised to the power minus 2, which is equal to 4 into 6 raised to the power 2. And the same thing continues with the other two parts, that is, if I take 1 upon 2 raised to the power minus 6, that can be written as 1 upon 2 raised to the power minus 6. Now I want to change it to positive exponent, so this will become 2 raised to the power 6. Or in short, what you can remember, that whenever there is a negative exponent in the denominator, like 6 raised to the power minus 2, if you want to make the exponent positive, take it in the numerator. So it becomes 6 raised to the power 2. Here also the negative exponent is minus 6. You want to make it plus 6. So take 2 in the numerator. So 2 raised to the power 6. 3 raised to the power minus 1, take it in the numerator, it will become 3 raised to the power 1. Then you can simplify it. 4 into 36 plus 2 raised to the power 6 will be 64 plus 6. This will be 144 plus 64 plus 6, that gives you 200. Sorry, this is equal to 150 plus 64, which is equal to 214. So this is how we use the laws of exponents in solving the questions. Let us do one more question, different type of a question. Suppose I take 2 raised to the power a upon 2 raised to the power b whole raised to the power a plus b into 2 raised to the power b upon 2 raised to the power c whole to the power b plus c into 2 raised to the power c upon 2 raised to the power a whole to the power c plus a. Okay, now I have to show that this entire thing comes out to be equal to 1. So let's start with LHS, left hand side. RHS is only 1. After simplifying LHS, we should get the answer to be equal to 1. Now look here, 2 raised to the power a upon 2 raised to the power b. Can we apply the law, the second law, 2 raised to the power a minus b, that whenever the bases are same in division, the powers, they get subtracted. Similarly, 2 raised to the power b minus c raised to the power b plus c, and here 2 raised to the power c minus a raised to the power c plus a. Now use the third law, in which we say when there are two powers together, those powers they get multiplied. So 2 raised to the power a minus b into a plus b. Here also 2 raised to the power b minus c into b plus c. And the third one is 2 raised to the power c minus a into c plus a. That gives you 2 raised to the power a square minus b square, 2 raised to the power b square minus c square, 2 raised to the power c square minus a square. Now here in all the three terms the bases are same and there is a multiplication sign. So by the first law all the powers will get added. A square minus b square plus b square minus c square plus c square minus a square. This will get cancelled, b square, c square, c square. So we get 2 raised to the power 0, which is equal to 1. So this is how we can solve many other problems using the laws of exponents.